continue. Okay, so I have to get all the way to 3.5 with you guys today, which is a lot of stuff. But here's the good news. So the other thing I was thinking about doing, like for example, operation of functions, that is part of college algebra chapter 2.6, right? Which talks about operations, except you guys don't really need to do composites yet, right? So literally we're just doing addition, subtraction, multiplication, divisions, right? And then when we get to 3.3, it was talking about even and odd functions, which we did in 2.2 in college algebra. And then increasing, decreasing, which is 2.2. We did relative max and min, which is the same as local max and min, but then you need to know more about the global max. I'm sorry, the absolute max and mins, right? And then the average rate of change was 2.4. So I was thinking about taking some of those videos and bringing them over so that in case you're like, because all of this stuff is supposed to be review for you guys. So I was thinking about bringing all of those over so that you guys can go, okay, great. I can now, if I need a little more detail on average rate of change, I can go here. If I need a little more detail on the functions, on the operation with the functions, I can go here so that this way you have a little bit more in depth of things that you guys forgot about already. Okay. Does that make sense? All right. So let's go ahead and let me go ahead and still cover operations. With functions. All right. So whenever you see f plus g of x, this just means f of x plus g of x. And similarly, if it says f minus g of x, you're just going to subtract the two. And if it's multiplying, you're just multiplying the two. And same thing with dividing. So here is where your spidey sense should kind of flare up, because we're dividing. That means there's a great chance that they might do something like this to you and then ask you for what the domain might be. Make sense? Because it's division, it's making a fraction right off the bat. You're like, ooh, they might ask this for domain. Okay. So just be ready for that. Okay, so that's 3.1 and 3.2. So let me see. So let's just do a quick example. Let's say that f of x is equal to 2 divided by x plus 3. And g of x is equal to x divided by x minus 4. Now, I could be nice and do like, hey, find f plus g of 5, right? I could be nice like that, which tells me that I just have to find f of 5 and g of 5 and add them. Which you get what? 1/4 plus 5. Is that what it is? That right? Oh, I'm sorry. This means yes. This means no. Sorry. Forgot to give you guys the ledgers. Is that right? So what is that going to give me? 21/4. No? Yes? So in case if anybody got lost on that one, 5/1, need a common denominator, 4. So that will give me 20 plus the 1 will be 21/4. Okay. However, chances are, since you're in pre-calc, we're going to say more something like this. We're going to leave it in X and not give you a number because that becomes much easier, right? So literally this is f of X plus the g of X. So that means you actually have to take the 2 divided by X plus 3 and add it to, of course you would do that, the X over X minus 4, right? Because this is a little bit more difficult of a problem. So since we're adding fractions, what do we need?
A common denominator.
Absolutely a common denominator. So we bring in the sisters, right? What do they have that I don't have? Well, the X plus 3 doesn't have an X minus 4. If I multiply that on the bottom, I have to multiply that on the top. And the X minus 4 is missing an X plus 3. If I do that to the bottom, I have to do that to the top as well. So since the denominator is the same, I can leave the denominator as one thing, right? Keep the denominator, add or subtract the top. Well, the top is going to be a 2x minus 8 plus x squared plus 3x. So I got to do a little CLT, right? Share loving tender. Or combine like terms. Actually, why am I even doing that when I can do this? Boop. This is much easier, isn't it? So I got x squared plus 5x minus 8. And I should always check to make sure that I can actually, well, to see if I can actually factor this trinomial. If I can, that way I want to see if anything else cancels. Can I factor this trinomial? I can. I cannot. Or can I?
I don't think so.
I don't think so, said by James. I can't find two numbers multiplied together to give me -8, but yet added together to give me 5. Is that right? Okay. Then I'm done. So let me ask you guys this. What's my domain? Huh? -3 and 4. That's what you were going to say, weren't you? Right? So it can be anything except for those two. Do we know why? Yep, those are only two things that can make the denominator 0. So let me write this more neater, more nicer. Right? And realize that when we're dividing, because we're going to have to copy, change, flip, you're going to have multiple of these domain issues, right? Or so-called restrictions, right? We call them restrictions before. Are we okay with this? Yes? You guys remember these? Sure, I guess. Well,
I
let me ask
remember
you.
them.
You don't?
I kind of remember, I should say.
Well, too bad. Too bad. So sad. All right. Well, here's the other possibilities. Sorry, James. Just had to do that to you. Just for poops and laughs. Okay. So let's say we're given graphs, right? So let's say this right here. Say bot. That doesn't give me a lot, Dodo. So that gives me more, kind of. Yeah, we'll do that. All right, so I got this, and we'll call this f of x, and I'll be nice and do this. Whoa, that seems really not so nice. That, yeah, that'll work. Okay, and I'll call this g of x. Can you guys please find f plus g of 4? Is that what we got? 4? Because this would be f of 4 plus g of 4, right? What was f of 4? And g of 4? Why did I put a comma? You're like, I don't know either. Wasn't really sure why, right? Does everybody understand how we got 0 and 4 to get 4? Are we sure? So
I'm a
f
little
of,
confused.
because f of 4. So what does this 4 and this 4 mean? Is my x values. Is that right?
Yes.
So if those are my x values, isn't the x value of 4 right here?
Okay.
So if this is the x value of 4, where does it cross the graph? Well, across the f of x right here. What is my y value at that point? It's 0. And if I was to graph this point will say 4, comma 0. And it hits the blue, which is the g of x right here. And that point right there is going to be 4, comma 4, because that's the y value here. It's 4, right? So if you guys notice, that's where the 0 and the 4 came from. Because that is what f of 4 stands for, right? So when I look at f of 4 and I translate this to English, this is what the f is y. No, just joking, guys. What is y when x equals 4, right? That's the actual translation from it, right? What is the y value when x value is 4? Is that better? Are we sure?
Yes, it's much better.
Much more gooder?
Much more positive.
Much more positive? So we're good. All right. So let me ask you guys this. How, if I was to give you a graph, how would you know if it's a function or not? Vertical line test. Awesome.
Vertical line test, yes.
And what if I gave you points? If I just gave you points, how would you know if it's a function or not? If the x repeats. Okay. And if I gave you an equation? Oh, I heard this before. Solve for y and then what?
See if there's two answers.
That's such a good answer. I don't need to plug it back in, but what I do want to do is the number one dead giveaway is a plus and minus, right? Anytime I actually take the square root of both sides, the plus and minus is the dead giveaway that I'm going to have two y values on one x value, or one input with two outputs, right? Okay, great. I think we're ready to move on to 3.3. So let's move on to 3.3. Which means we still got to cover 3.4 and 3.5. So this might be going a little bit faster than you think. All right, so 3.3. Properties of functions. Why am I yelling? So, okay. Apparently I offended someone. Even functions. Even functions. What can you tell me about even functions? Huh? It's symmetry about the y-axis. They are even. They're pretty balanced, you know. Yes, they have symmetry about the y-axis. So if I was the y-axis, symmetry means that if I had this point right here, x comma y, what would be symmetry to it? What's this side going to be? If this is x comma y, this point right here, my hand being the point x comma y, what would this point be then? Not y comma x. That would be this. It'd be negative x, right? Because the x is no longer positive. It's on this side, but the y value is exactly the same, right? As my dad would say, exactly. Yes. So my x comma y would be now negative x comma y. So what does this tell me? This tells me that if I was to put in a negative x in for x, I would still get the same exact y value. Yes? Okay. So now let's translate this to function notation. Like, I can't translate that to English. I'm going to translate to function notation. So what this is telling me is this. If I replace the x with negative x, right? I will still get the same y value. Because f of x just means y, right? Does that make sense? So it's saying, okay, my y value when I plug in negative x, that's what that's saying, right? What is y when x is negative x, right? When I plug in negative x in for x, my y value is still going to be the same as the original y value. That's what that's saying. Apparently I lost someone else. Someone's like, oh gosh, I'm lost. All right. So remember that. An odd function. This is what Alfredo was talking about, right? It's symmetry about the origin. So if I have my point here, it's not this way, it's actually this way. Yeah, this way. That's better, right? So it's, if I start out with x comma y, what is it now? What do you mean negative x, negative y? Because now it's on this side, right? Which is negative. Well, in your, I guess I should have done it this way, right? So so I should have done it this way, right? So if it's x, y, now it's going to be negative x and negative y, right? So now we got to translate that to function notation. Oh gosh. Oh gosh. How do I do that? Man, you guys are so helpful. Let me write this to delay a little bit for you guys to think about it. Still nobody? Dang it. So this is telling me if I put in negative x for x. If I put in negative x in for x, what is that going to equal to?
No, positive x.
Oh, okay. I didn't see what you're saying. Right, I get a negative y value, right? And that's all this is saying, right? This is just a negative y, right? So it's saying if I plug in a negative x for x, then I should get a negative y coming out. So how many people has lost it? So here's the thing. So the part that you have to remember, because, okay, how about if I put it this way? Let me see if this will help. Let me do the same thing here. Does that help? Because the ones that, for the ones that make sense, they're like, yeah, this helps. But you guys already knew that, right? It's the ones that don't understand. So essentially, when I start off with a point that's just x comma y, I know if I reflect it over the y-axis, my x would change, but my y wouldn't. So that's why in here I had to change my x to be negative, but my y wouldn't change. My y would still stay exactly the same. Okay, and that's why there. So here, if you notice, it's the same exact thing happening, right? But with this one, because my x changes and my y changes, so that's why I had to change my x, and I had to change the result of it as well. Again, remember that x and y, x comma y, is an input and an output, right? So if you notice that over on this side, both of them are inputs. This is the output, right? So now, how will I put it this way? Once I show you how to determine if a function is even or odd, you might not care about what I just wrote. Is that fair? So let's say the question is, so I'm given the f of x. I gotta find out if it's even or odd. So here's the first thing I would do. First thing I would do is I will find negative f of x. So if I was to negate the f of x, what is that going to equal to? What would that equal to?
Would that be 8x cubed plus 6x?
Right? It tells me to negate the function. So in other words, I'm just going into the function and negating everything. That means anything that's negative becomes positive, anything positive becomes negative. Or distribute a negative one through. Yes, no? We're okay there? All right. So now, step 2. I'm now going to find f of negative x. So, which means anywhere there's an x, replace it with negative x. So I have negative 8 parentheses q minus 6 parentheses, and replace those with negative x. What is negative x raised to the third? Still negative x to the third, right? Times 8 is going to become a positive 8x to the third. What is negative 6 times negative x?
6x.
What he said. I don't know. So the question is, does this result look like f of x, or does it look like negative f of x? Okay, so check this out. So even before I did this, right? Maybe I should have pointed this out. If it looks like this, then it must be odd. If it looks like this, then it must be even. Does that make sense? And since this looks like that, then it must be odd. So now I can say that f of x is equal to negative So if anyone want to take a picture of that, welcome to do that. Now, if it looks like the original, that must be even. Eventually, Giselle is going to be able to stay in the class. Any questions on that? Does anybody feel like they need to punch me in the face? Okay. All right. Next, let's talk about increasing, decreasing, and constant. Man. Let me do this. Let me rewrite that. That looks ugly. That was more gooder. Now, the part that you guys need to know about increasing, decreasing, constant is that these are always going to be open intervals. These have to be open intervals because when it transitions from increasing to decreasing is a transition point. So we can't really tell you if it's increasing or decreasing or if it's constant during that one point. So that's why it's open intervals. Okay. So what does it mean by increasing, decreasing, and consistent means, or constant? So if I had a graph, right, and I put down, I don't know, something like this. Right? So everything that we do is about traveling left to right. Of course I didn't do that. Why would I do that? Close enough, right? So as you go from left to right, you can see where it's decreasing, right? So decreasing wise, it would be from negative infinity to -4, right? And six to infinity. And then with increasing, it'll be from 2, -1, union with 3 to 6. And then constant would be as I twirl the straight line. Yes, the 3. And notice how they are all open intervals. Yes. Because it started increasing right from here, right, to here. So that'll be a -4 to -1, right? Because here's the thing. So if you guys ever wonder about, hey, should I be using X values or Y values for these numbers, right? So think of it this way, right? If you were to peek through a little sliver of interval, right? An interval of window, right? If I was to peek through 2 horizontal windows, meaning using Y values, if I do this, I see that whole curve, wouldn't I? Right? I see all the increasing, I see all the decreasing, I see everything. But if I only open the window this way, which is my X values, then I can only see bits and pieces of that graph. So that should remind me that it's only X values that I'm looking at and not ever Y values. Okay. Does that help? Okay. there's something else I wanted to do, but okay. So while we're on this graph, we can also talk about local, max, and min. So local max and min is very much like relative max or min. These occur in the peaks, or yeah, in the peaks or valleys. Right? And it's going to be local based on what kind of graph is given to you. Does that make sense? Okay. And again, it's only a peak or a valley. There is something about the global max that I had my head around, and now I am blanking out. And that is why I'm flipping through these pages right now, because I'm like, what was it? What was it? What was it? What was it? And I can't remember still. So hopefully it'll come to me as I go. So the other one is called absolute max and min. So if you notice that local max or min occurs at the peaks and valleys. And the way I explained this before was, you know, just because I like to, just because I'm at a bar with my volleyball friends, I would be, relatively speaking, the shortest one there, right? Because relatively speaking, volleyball players are typically tall. So therefore, I'm going to be the short one there, right? They'll make short jokes. It happens, right? They'll tell me to stand up when I am standing up, right? But at a classroom, I might be telling people to stand up when they are standing up, right? I can make short jokes now, right? So it's a little bit different. But again, a local max or min would be exactly that. Locally, at that point in time, at that bar scene, with Chan, with his volleyball friends, what does that look like, right? At that point in time, I'm a local min, right? Where, heck, if I went back to Japan, I might be a local max. I don't know, right? If I went back to China, then Yao Ming is there, then I'm definitely not the local max by any means, right? So those are local, but it doesn't mean that that's the absolute max. Doesn't mean that I'm going to be the shortest one in that town, just in that bar scene, but not in that town. And that's where the absolute is. So the absolute could occur at a peak and valley, but not necessarily, if that makes sense. Okay. So, for example, so in the graph on the left, this right here is my absolute max. And this right here is my absolute min. While here, this is my local max. And this right here will be my local min. See the difference there? In the blue, this point right here is my absolute max, and it's also my local max. This right here is my local min and also my absolute min.
I'm a little confused.
Why?
I don't get the difference between the two graphs.
Is this point the highest point in this graph?
Yes.
That's why it's the absolute max.
Okay.
Is this the highest point in this graph?
Yes.
This is too?
No.
It's not.
No.
But it is a peak. Yes?
Yes.
It is a peak. So therefore, it's just a local max.
Okay.
This is not the lowest point on the graph, but it is a valley.
Okay.
So that's why it's a local min. Where
Okay.
this is the lowest point in the graph, so that's why it's an absolute min.
Okay.
This is the lowest point in the graph, yes? Valley.
Yes.
Same thing. It's the highest point, and it's a peak, right?
Okay.
But you guys got to be careful. So one of the graphs that is being shown here is something like this. Because that might seem a little trivial to you guys, what I just showed you, but let's show you guys this. Because this is something I do want to show. Is there a highest point?
Yes.
The answer is no. Because we can look at this as a highest point, but it's not. It's not a peak either, because it doesn't exist. Because it's an open circle. You might want to say, whoa, how about this? This would be the absolute max. But it's not. Because it's not the highest point. We don't know what it is. Not the absolute, but the local. Because I know that there's something higher. Right? But that wouldn't be my absolute max. Because I don't know. Is it going there? I don't know. Because this arrow just means it continues on. I don't know the fact that it's going, whee! Right? I don't know that it's not coming back down. This right here is a valley, but it doesn't have a bottom because it doesn't exist. This right here doesn't exist. It's not the lowest point. So in this graph, there is no global max, or what did I call it? Absolute max, sorry. No absolute max, no absolute min, no local max, and no local min. Dang, this graph sucks. Does that make sense? Now, don't get me wrong. They might say, hey, I'm going to give you an interval. I'm going to give you a window. Right? So let's say they give you a window like this. Right? If they only give you a window like this, then you can talk about a global max and a global min. Does that make sense? Because then it's cutting everything else out and just blowing that piece up. Yes. In this case, yes, if they only give you an interval. So let's say let's give you an interval. Let's say let's make this a little nicer. So let's say something like this, right? So let's say, hey, I want you to focus at x such that 1 is less than or equal to x, which is less than or equal to, actually less than, just less than, yeah, just less than, sorry. Three, right? So if I was to give you that, then I'm only focused on just that window, right? In that case, then I would have a global max and a global min, but no local max or min because there's no peaks or valley in that window. Yes. In the green? In the whole thing? In this whole thing? Oh, sheets. It does. It does. But the problem is that there's nothing here. It's open. Where it's supposed to be, it's not there. Yeah, it's like, it's supposed to be right here. Yeah. It's like, psych. Right? So that's why it just doesn't exist. It's like, it's supposed to be right here. It's like, and then it continues on. So that's the reason why there's no local. Because it doesn't exist. Now, if this open circle was like over here, then it's no big deal. Because I can still have that, right? And then I did say on here, I put this in here, that this must be in a closed interval. So that means this right here, I do have to use this as equal to, because it has to be a closed interval. Are we okay there? Seems like so much information. And I know it's a lot. Do you guys remember what the average rate of change really stands for? This is really slope.
Yeah, that's what I was going to say. Slope.
Yep. So if it's slope, I remember this, right? That's why I remember. Okay. Well, here's the thing. Since we already went through the process of translating this into function notation, we're going to do it again. So what does that make average rate of change equal to? Why is it F? right? Average rate of change, not fringe. All right. So that is going to be what? How do I write y sub 2 as a function notation?
Was that like f of 2 sub 2 minus f sub f of x sub 1?
Right? And
Yes.
what else did I mention so far this week that is also about the slope? I said something else that was also, it really means the slope.
The difference quotient.
Yes. The DQ, the Dairy Queen. Okay, so all three of these mean slope. I hate your homework. Like, so do I. Okay. The secant line. So you guys have you guys ever heard of tangent line before? Yeah. So
I think so.
okay. So if I had a graph, if it would give me a parabola, there we go. Let's just make it wider. That will make it work. Okay. So a tangent would be something that would be like, if I was to pick an x value, then a tangent line would be tangent to this part here. Right? So this would be called a tangent line. Okay. Now a secant line, however, would be you picking a point here and picking a point that you can read here. This would be called a secant line.
I have a question. For the secant line, does it always cross at 2 locations?
Yes.
And for the tangent one, it only crosses at 1 location?
It doesn't cross anything. It's just tangent to it.
Oh.
It's just laying on it. Laying nicely parallel to that point. Yes. What? The tangent line, it just literally lays along the outside edge or the edge of, no, the edge of the graph. The secant line basically cuts the graph. How's that? Okay, and usually we're given the 2 points to where it cuts. Right? Now, it's a lot easier for me to find the equation of a secant line than the tangent line. Okay, so it's a lot easier for like, why is it easier for me to find the equation of the secant line? Because I have 2 points. And to write an equation of a line, I need what? Well,
2 points.
a point and a slope is the 2 things I need, right? To write an equation of a line. So if I have 2 points, I already got a point, right? And with those 2 points, I can find my slope. So therefore, I got all the information I need to make that happen. Okay. But usually the secant line is not that wide. Okay. Usually it likes to the distance a little bit smaller. Right. So if I didn't draw this tangent line here, then I would probably tell you that it would want a secant line that is more like this. Okay. More like that. Does that make sense? Okay. Where it's kind of like it's getting closer to what is happening along that curve. Right? Is approximating what that curve, that angle of that curve might be, or the slope of that curve might be. All right. It's getting close. Rather than something like this. All right. Are we okay there? So far, so good? Yeah. Yep.
So the tangent line is just 1 point, yeah?
Well, it doesn't matter which point. Well, like I said, chances are I'm just showing you what a secant line looks like, right? Where it cuts that graph. So you want to use those 2 points to find the slope of that line so that you can write the equation of that line. Chances are it'll look more like the blue line because it's going to be number one, a smaller distance from X to X, right? And then that way it approximates the slope of that part of the curve a little better. Because obviously the smaller this gap is going to be, the better approximation it would be to know the slope of that part of that curve. Right? Does that make sense? All right. So, but this is just a bigger illustration of what that cut of a secant line would be. Okay. So let's put it, for example. So let's say, so you guys could get something like this. So if I say, find the average rate of change. I was about to put F again. Oh, OF of change. That's why. Of f of x is equal to x squared plus 5. And part A says from -2 to 0. Do we get it yet? All set? Yeah. How do you find f of -2? Did we get the -2? Yes. We understand how we got
Yes.
negative. Do we understand how we got -2? I'm very scared for you guys right now. Find the secant line. Okay, I should say find the equation. Oh no, I can't find the equation. Yes, I can. No, I can't. Yes, I can. Yes, I can. Yes, it's the same equation. Yes, it's the same distance of -2 to 0. I want you to find the equation of that secant line. Are we confused on what to do? So again, a secant line is what? There's a line that cuts, right? So if I have this, I have this, I have this. I'm assuming this is what this is. I have no idea what is a parabola. It's a smiling parabola. Actually, I do know what the heck this is. Why am I so dumb? Actually, you guys all know what this is, actually. You guys know what this is?
Is it parabola?
Here's a parabola moved up 5 units, right? It should look like something like this, right? Okay. So I guess I should do this. So I'm going from -2 to 1. So I'm literally going from, I mean, -2 to 0, right? Okay. So I'm literally doing this right here. Right, I'm doing something like that, right? So this right here is f of x equals x squared plus 5, right? So I want to find the equation of this line. Which is a secant line. In order to find the equation of this line, what do I need? NA.
2 points.
I just need 1 point.
Oh.
Plus what? You better say plus 5. Now that I drew it, yeah. But how would you have found it here? Point slope form, yeah. So if you guys look at this, right? So here, with the average rate of change, you have found a slope. Is that right? You found a slope. So now you just need a point. You have a point. Was it -2.9 a point? Oops. It shouldn't be -2.9. Apparently, huh? It came out that way?
Yeah.
So my graph was actually wrong. No, it's not. It wasn't. Never mind. Because I moved up 5 units. So the 4 would have went up to 9. So I would have already have a point of -2.9 or 0.5. Right? So I would have had a point. I would have the slope. So now we're going back to 1033 of finding the equation of a line. Right? Now, does all of this look like things are hidden? Yes. Right? Because we're not used to looking at this as the y value. And the x value is -2, right? We're not used to that. I understand that. But we got to start getting used to it. Right? And that's the reason why we gotta have to see these forms for that reason. And that's also the reason why when we look at the difference quotient, we gotta be able to see that we are talking about slope here. Right? Because this x right here is a certain location. Right? X plus h is just I move. And that's the thing. Right? I'm not moving a big bit. Right? So in that previous problem, that we just did, right? The distance that we moved just happened to be 2. Or in this case, -2? No, 2. Because this would be, yeah, it would be 2 spots, right? Does that make sense? So the h would literally be 2. Everybody see that? Because the width of it was 2, so I just moved 2 places, and that is my f of x plus 8. And then the difference of those two would just be my 8. You guys see that or no? Yes? Okay. So we got to be able to see that the difference quotient is my slope, my